Hey, what you doing?
Oh, I'm doing a project.
But what's your project on?
Oh, it's on the evolution of galaxies. Do you want to learn about it?
Yeah?
Alright, well, here, I have a friend who's helping me with my project. She's doing how the Big Bang started galaxies. Want to take a look?
Yes?
Hey, Nicole, I'm here with my little brother, and we were wondering how long after the Big Bang it took for galaxies to form.
Hey guys, well according to the Big Bang Theory, the universe began expanding from an infinitesimal volume with extremely high density and temperature. Tracing back this expanding universe, we see that the separations between galaxies become smaller while the density becomes higher. This continues until all matter is compacted into a completely shrunk volume of the universe with an incredible density, which is the moment of the Big Bang. We can estimate how long ago this was by dividing the distance of the galaxy by its recessional velocity. This way, we estimate how long ago the distance between the galaxy and ours was essentially zero. Calculations show that the Big Bang occurred as long as 10 to 15 billion years ago, which is about 3 times the age of the Earth. As a way of checking this estimate, we can examine the oldest things we find in the universe to verify that they are 10 to 15 billion years old, but definitely not older. From radioactive dating of uranium isotopes, we know that the oldest isotopes were created about 10 billion years ago. From our current model of star evolution, we know that the oldest stars in our galaxy are about 12 billion years old. These ages are consistent with the age estimated from the observed expansion of the universe. This agreement suggests that the universe really began a finite time ago, providing an encouraging reason to believe in the Big Bang model of the universe.
Huh?
Yeah, maybe my friend Vespia can help us out. She can tell us why the galaxies were formed. Hey, Vespia.
Hey guys, so with the origin of structure in the universe, there's density enhancements that take place, and they're known to have two routes. They can either grow or disappear to the expanding universe. There are two ways the structure could have formed, given that there had to be enough matter for the gravity to overcome expansion. One way is either large structures the size of galaxy clusters formed first, then broke into galaxies, or the second is dwarf galaxies first formed and merged to make larger galaxies and clusters. So with this, there's like two scenarios that can happen. There's the top down, which are large pancakes of matter that form first, then fragment into galaxy-sized lumps, and the bottom up, which is small dwarf galaxy-sized lumps form first and then merge to make galaxies. So with all this, there's a protogalaxy, which is a large lump of dark matter and gas that over the time of recombination, and it collapses under its own galaxy. Well, after the galaxies form, they can still change their appearance, there's galaxy collisions, which is when a galaxy cluster often passes near each other, and the close passage will cause tides that cause the clouds to collide. And then lastly, with stars in the galaxy, the star formation starts with the collision of two gas clouds. The collision produces a shock of high density, and a star cluster forms at the shock region, and the newly formed star heats and the remaining gas and dissipates the cloud. So that's pretty much it about galaxies, the origin of galaxy structures and stars.
That was confusing.
Yeah. You know what? I have a friend named Brooke who was looking at how the galaxies formed. She could even tell us how we know the galaxies formed. Let's ask her. Hey, Brooke.
Hey, everyone. Determining information about the evolution of galaxies can be extremely difficult. Although we are able to determine the life cycles of individual stars, we are not yet able to determine those of galaxies. This is because of the great distance we have from them. We do, however, know that galaxies evolve through their interaction with other galaxies. When many smaller galaxies are surrounding a larger galaxy, the larger galaxy seems to swallow the smaller galaxy, forming one large galaxy. This is known as galactic cannibalism. In 1929, astronomer Edwin Hubble discovered that all galaxies were moving away from Earth, meaning the universe was expanding. In observing this, many other discoveries were made about the universe as well. While all galaxies are being spread apart due to the expansion of the universe, each individual galaxy is remaining stuck together. This is due to forces within each galaxy. Also from this observation came the Big Bang Theory. This theory states that at one time all of the galaxies were on top of each other, but as time progressed, everything began to expand and spread apart. This means that the density of matter was higher during these earlier times. Galaxies are being spread apart due to the expansion of the universe. Each individual galaxy is remaining stuck together. This is due to forces within each galaxy. Also from this observation came the Big Bang Theory. This theory states that at one time all of the galaxies were on top of each other, but as time progressed, everything began to expand and spread apart. This means that the density of matter was higher during these earlier times.
Man, that was cool.
Yeah, that was pretty cool. Do you like stars?
Mm-hmm.
Well, I have a friend who can tell us how and where stars form. Her name's Lexi. You want to see?
Mm-hmm.
Alright. Hey, Lexi.
Hey, Loxie.
Hey Evan! Well, the answer to your question is stars can actually be formed in any part of the galaxies. The way stars are formed is they're clouds full of dust which scatters throughout the universe. Gravity causes the center of the clouds to collapse, which causes them to become known as cores. This core heats up and it becomes known as a protostar. The remaining dust of the cloud becomes asteroids, comets, planets, or even remains as dust. I think this should answer your question. Bye!
I don't get it. Alright. You're confused face. Let's see your confused. That was good confused face.